Before we solve this problem from 2022 final exams, let me introduce or remind you of a few basics with regards to a quadratic number pattern, right? So the general term of a quadratic number pattern is given by Tn is equals to an squared plus bn plus c. So let me show you something real quick. So if we have a quadratic number pattern with terms 1, 4, 9, 16, 25, then we can take the first difference of any two consecutive terms, right? If we do that, the difference between 1 and 4, that is 3, 9 and 4, that is 5, right? And then 9 and 16, that is 7, and then 25 and 16, that is 9. We can go ahead and take the difference of the first differences, right? So if we do that, we get 2, 2, 2, right? So with this, with what we have here, we say that 2a is equals to this common difference that we have, right? We have 2, 2, 2, 2, 2, right? And then 3a plus b is equals to the first term of the first difference. So for this quadratic number pattern, 3a plus b should be equals to 3. And then a plus b plus c should be equals to 1, right? The first term of the number pattern itself, right? Now you might be asking yourself, why is 2a equals to the second difference? Why is 3a plus b equals to the first term of the second difference, right? That is actually easy to prove, right? But then for the sake of time, we can do that on a separate video. But then here, I just want you to realize that 2a will be equals to the common difference, and then 3a plus b should be equals to the first term of the first difference, and a plus b plus c should be equals to the first term of the number pattern itself, right? So with these basics, we should be able to answer these questions, right? So let's go ahead and see if we can use any of these to answer the questions we have. It is given that the general term of a quadratic number pattern is Tn is equals to n squared plus bn plus 9, right? And then the first term of the first differences is 7, right? And then the first question 3.1 is saying that let's show that b is equals to 4. So let's go ahead and look at the general term we're given here. Instead of c, we have 9, right? So we already know from the get-go that c is equals to 9, because we know fully well that the general term is Tn is equals to an squared plus bn plus c. So instead of c, we have 9. So we know that c is equals to 9, right? And then instead of a, we have 1 here, the coefficient of n squared, right? So we know that a is equals to 1. And then now we're looking for b, right? But then if you look at this rule that we have here, right? We said that 3a plus b should be equals to the first term of the first differences. And then in our equation, we are told that the first term of the first differences is 7, right? So we know that 3a plus b is equals to 7. But then we're saying that a is equals to 1 because that is the coefficient of n squared. So we're going to have 3 multiplied by 1. We have 3 multiplied by 1 plus b being equals to 7. So if we take 3 to the other side, we're going to have b being equals to 7 minus 3, which is equals to 4. So we have proved beyond reasonable doubt that indeed b is equals to 4, and we can move to 3.2. So 3.2 is saying that let's determine the value of the 60th term of this number pattern, right? So now that b is equals to 4, it means that our general term of the quadratic number pattern will be given by Tn. So we have Tn being equals to n squared plus, instead of b, we have 4, and then plus 9, right? So if we want to find the 60th term, we're going to have Tn being equals to, instead of n, we have 60 squared plus 4 multiplied by 60 plus 9, right? So 60 multiplied by 60, that will be 3,600, and then 4 multiplied by 60, so that is 612, and then multiply that by 2, so we have 240 plus 9. So the 60th term should have a value of 3,849. So that is the answer for 3.2. And now going to 3.3. 3.3 is saying that let's determine the general term of the sequence of the first differences of the quadratic number pattern. Write your answer in the form TP is equals to MP plus Q. So the sequence that is formed by the first differences of a quadratic number pattern, it's always an arithmetic pattern, right? So we already know that we should have a sequence that has a form Tn is equals to A plus n minus 1 multiplied by D. A is obviously the first term, right? We know that for an arithmetic sequence that A is the first term for an arithmetic sequence. So let's go ahead and find out the first differences created by our quadratic number pattern, right? So let's not forget that for the quadratic number pattern, we have Tn being equals to n squared plus 4n plus 9, right? So let's go ahead and find the first term. So the first term, we substitute in 1, right? So 1 squared, that is just 1, and then plus 4n, that is just 5, plus 9, that will be equals to 14, right? And then now we can say 2 squared will be 4, and then plus 4 multiplied by 2, that is 8 plus 9. So we basically have 17 plus 4, which is 21, right? 17 plus 4. And then from there on, let's substitute 3 squared, that will be 9. So let me erase this and write what I'm supposed to write. So we're gonna have 9 plus 4 multiplied by 3, that is 12. So 9 plus 12 already, that is 21, right? And then plus 9, that should be 30. So the third term of the quadratic number pattern is going to be 30 here. So if we find the differences here, 21 minus 14 should be 7, and then 30 minus 21 should be 9, right? So we have 9 here, right? And then the third term is going to be 11, right? Because for an arithmetic sequence, the difference is the same, right? So now let's go back to our equation. We said that Tn is equals to A plus n minus 1 multiplied by D for an arithmetic sequence, and then A is the first term. So now we can say that Tn is equals to 7, the first term, right? Plus, let me just write that in white, plus multiply by n minus 1, and then the difference here is 2, right? The difference between 9 and 7 and 11 and 9, so multiply by 2. So Tn will be equals to 7 plus 2n minus 2. So now we're going to have 2n plus 5, right? So that is the general term of the sequence made by the first differences of a quadratic number pattern. The sequence that is made by the first differences of a quadratic number pattern, it's always going to be an arithmetic, right? Yeah, that is always true. And now the last question, 3.4. So we have 3.4 here, saying that which two consecutive terms in the quadratic number pattern have a difference of 157? Which two consecutive terms in the quadratic number pattern has a difference of 157? Because we have an equation of the pattern created by the first differences, we can easily find the position of the number 157, right? But then after we do that, what do we do? Let me show you something. So let's say we have x, y, z being our quadratic number pattern, right? And then the difference is a and b, right? So I want you to realize something here. B is T2, right? It's term number 2 on the first differences, but then we get it by finding the difference between T3 and T2. Now let's look at A. A is T1 on the first differences, and then we find it by finding the difference between T2 and T1 on the quadratic number pattern, right? So if we find that 157 lies on position 1000, then that will tell us that 157 is between the term 1001 and 1000 on the quadratic number pattern, right? So let's go ahead and find the position of the term 157 so that we can know where it lies on the quadratic number pattern, right? So because we have that formula for the first differences, which is 2n plus 5, we can equate it to 157 so that we can find n, right, which is the position of the number. So if we do that, we're gonna get 2n is equals to 152. Divide both sides by 2, which will get 76, right? So now we know that 157, it lies between term 76 and term 77.